Thank you everybody. Thank you for allowing me to present PRISMA mission. I hope that everybody could hear me well. And as you said, my role in Italian Space Agency is the mission director of the PRISMA mission. I will show you in this presentation, which was so also the contribution in preparation of Patrizia Sacco, which is actually the mission manager of the mission, and we show you briefly some characteristics of the mission and some hints in order to become a user and exploit it. So PRISMA is an acronym. Could you please confirm that you could hear me?
Yes.
Okay. Perfect. PRISMA is an Italian acronym, is in Italian precursore iperspettrale della missione applicativa, which means hyperspectral applicative mission precursor. Precursor means that this mission, differently by Cosmos Chemed, which certainly you know, the constellation of synthetic aperture radar made by Italian Space Agency is quite different from that mission, because Cosmos Chemed is an operational mission, while PRISMA is just a precursor, so a demonstrator. I made that demonstrating and qualifying in orbit, so in a relay context, the hyperspectral and panchromatic sensor, and also the ground processor, of course, on ground. So the idea of this mission is just to make not a test, but a prototype, a technology demonstrator, pre-operational in a certain sense. The mission has opened its gates in May of 2020, so 2 years ago. The main mission portal could be reached at https prisma.asi.it, and the mission is based on an hyperspectral sensor which acquire sun-reflected radiation over the Earth's surface between 400 nanometers up to 2,505 nanometers, split in two overlapping bands, visible in near-infrared and shortwave infrared. The first one from 400 up to 1,010 nanometers, the second one from 920 up to 2,505 nanometers. The spectral resolution is quite good, is better than 14 nanometers. And the sensor and of course the products have a medium spatial resolution of 30 meters and medium SWOT 30 kilometers. But there is an added capability, a panchromatic camera covering the panchromatic range, so 400 up to 700 nanometers, with a 1/6 of the pixel size, so 5 meters resolution instead of 30 meters. So it's quite useful, as I will discuss in next part of my presentation, in order to allow the very accurate and precise geolocation of the data. The mission main mode is the primary, so-called primary mode, is manage user requests. Requests are coming from user. Requests could be new acquisition or existing product generation, and they are managed on the basis of priority and quota. Quota is related to the how much percentage of the system resource you could use, and the priority is used in order to solve programming conflicts about new acquisition. We also allow a priority in order to acquire data with different level of as linked to different level of importance. The main in the top level importance is related to acquisition over calibration validation sites, but we also allow user to ask us to put in so-called very urgent, so at top priority, even non-calibration validation site requests. For example, in case of mandatory PRISMA acquisition, a typical example is when a user or a group of users are doing some ground calibration or ground truth acquisition, and need that the PRISMA acquisition is done in contemporary with the ground activity. We also have a background mode, which is used in order to fill up the unused system resources daily, and is used in order to cover and acquire the land masses when there are no outstanding requests from users. We have 4 kind of products. Level 1, they are divided, labeling with the level of the products. Level 1, which is the lowest level, in a certain sense, is top of atmosphere radiance, which is radiometrically corrected and also calibrated, and includes some masks like, for example, cloud mask or sunblind mask. Level 2B is geolocated at bottom of atmosphere, so no more top of atmosphere, but bottom of atmosphere, and this is the radiance. The same product, but in reflectance, with added layers like aerosols characterization or water vapor map or cloud characterization constitutes the level 2C. Last level of product is the level 2D, which is simply the level 2C, so at bottom of atmosphere reflectance, but geocoded. Geolocated means that the product is only for labeled. The corner of the product are labeled, and you could find in the metadata also what you need to geolocate the pixels. The geocoded means that the product is completely superimposable with the map. So it's you do not need to process the geolocation data inside the metadata, but the product is automatically referenced to maps in a cartographic projection. The absolute hyperspectral radiometric accuracy is better than 5%, both top of atmosphere or bottom of atmosphere, and the geometric localization error is actually 200 meters, which is quite coarse value, but we have planned, and I will show you in the next slide, of a project in order to generate ground control points all over the world and allow in this way to reach the highest localization, the most finest localization capability of PRISMA, which is 15 meters. This thing could acquire 223 image each day and process 200 of them up to level 2D, which is the most demanding in terms of processing power product. And we measured the average response time, which means from the time ranging from the user placing an order and the same user getting the product. We measured this number in a quite long period, almost 1 year, and we obtained 7.5 days measured in such a long period. So quite a stable number, quite reliable number. Image could be acquired worldwide, but the system needs to have a solar zenith angle, so illumination condition of at least 70 degrees, below the 70 degree. Our data policy is quite simple. We only, in short words, in very simple and short terms, we only require that the user register into the system and do not redistribute the data. So it's not a completely open data policy that we call the quasi-open and free, because products are released for free, and we only ask to the user not to redistribute the data. But data, nevertheless, could be redistributed within the user group. User structure within PRISMA is based on or a single person group or a multiple persons group. And in case of multiple persons, you can share the data within the group, but you cannot share the data among different users. It's a very, very, we think, low impact constraint on the data policy, and data are, however, released free of charge, both for non-commercial users, but also, this is a recent addition to our data policy, also for commercial exploitation. We allow to use the data, which are still released for free, we allow people to use the data also to make money. We only require that the first, the so-called main user, the top of the user group, which is a single person, should be an Italian person belonging to an Italian organization active in the field of remote sensing. But the rest of the group, and group could be as large as 36 persons, so quite wide group. The rest of the group is not required to satisfy this constraint, so could be even from non-Italian person, could be even from non-Earth observation companies. So quite completely free. The participation to this group is completely open. In this way, we allow also commercial exploitation of data, still releasing, again, I want to stress this, still releasing data for free. We also have a page actually is shown in this slide in red, the address. It's a page in order which contain a code which is useful in order to forecast the PRISMA passages over a certain area of interest you specify. And this is quite useful in order to place an order, but you can, however, place the order without knowing this. It's just useful if you want to know at which time PRISMA make an overpass on your area of interest. About the high geolocation accuracy, as I said before, we are completing generation of ground control points all over the world, all over the land masses of the world. And this is made by an automatic processor exploiting the Sentinel-2 image. And in order to generate ground control point all over the world, and this ground control point will be used starting from the first quarter of next year, in order to allow the generation of geocoded product, level 2D, with the best geolocation accuracy, which is, as I said before, 15 meters. We also are starting another project, which is called the PRISMA Toolbox. Is about the reuse of a system which was internally developed by an Italian company called Planetech. Maybe some of you know this company well. It's based in South Italy and exactly in Bari, which is close to Matera, in which there is the receiving station of PRISMA. And this company has developed internally a toolbox, which is capable to ingest the PRISMA image and show them and process them for visualization in a very easy and fast way. And we have this plan, we are starting this project in order to simply acquire from this company this toolbox and freely distribute it to the PRISMA community. And this toolbox will be also upgraded in next future in order to ingest also Nmap, with certainly a lot of person from the audience knows, is the German hyperspectral mission, which was launched in last April and is completing the calibration validation commissioning phase. And this toolbox, as said before, will be also capable to ingest Nmap data, Nmap products. About PRISMA data quality will be in the next presentation of Federico, I believe, will be more detailed on that, but we have started just a few months away from the launch of the mission, a project which is called Prescav, PRISMA Calibration Validation. It's about calibration validation and verification of the quality of PRISMA over a network of 12 instrumented sites, all in Italy, which cover various kinds of Earth surface like snow, sea, island, and coastal water, and so on and so forth. And I will not I will not go inside with more details because you will receive, you will see a more detailed presentation than this. I wish just to remark the very good quality, which was measured on about PRISMA data, comparing it with Sentinel-2 or with AVIRIS, with a sensor, airborne sensor of the NASA, USA NASA, which flown last year, 2021, and there was a lot of comparison about the quality of PRISMA data against both AVIRIS and against also others calibrated sensor, like, for example, DASIS, which is on board, is a German hyperspectral mission on board the space station, but also with Sentinel-2 and 3, and this measurement show a very good quality, at least except in very few cases like this open water, but it's not a problem on the instrument. The PRISMA instrument for thorough analysis showed that there is a poor atmospheric correction in low reflectance areas, and this explains why you see so low in a certain way .52 R square statistics parameter. About the users of PRISMA, the user community, updated at June of this year, we had, now they are certainly more than that number. We have more than 1,400 licenses. Each license normally includes more than one person, because the structure of the group could include more than one person. So there are certainly more than 1,500 users, PRISMA users. As you can see, the 15 nations cover 80% of the users, and the Italian users are only one fourth of this of the entire population. So showing that PRISMA is well received, well appreciated, especially outside Italy. 60 for a scientific demonstrator like PRISMA mission is normal and quite well expected that largest part of the user community is related to science. It is exactly what we obtained from this statistic. 64% of the total users are scientists. And again, 52% of them are not Italian, not Italian, so showing that there is a lot of usage of PRISMA data outside Italy. Institutional and commercial users together represent 20% of users. And for another important number is that foreign commercial users, 80% of the total users, is 2 times of the Italian commercial. So again, witnessing appreciation of the mission outside Italy. The range of the thematic applicative areas cover a lot of areas, from agricultural and cover geology and so on and so forth. And PRISMA Scienza is a project of the Italian Space Agency devoted to support the Italian community on...
Ettore?
Yes?
I'm sorry, you have 10 more minutes, just to consider to leave a space for question.
Okay, I will close in a few slides. PRISMA Scienza is about supporting the Italian community on scientific applications and new services. This is the archive updated at mid of June of the last year, and shows you the coverage of PRISMA data acquired all over the world. You can see that it's the entire land masses are well covered, except few areas, mostly due to bad meteo, like for example the northern part of South America or even Middle Africa. Just a few slides about how to register into the system. You have just to fill up the license, and this is an example of the main fields you have to fill. Project title, a very short description of your project, your personal information like name, surname, and company, and so on and so forth. You have to go in this site, prismauserregistration.asi.st, submit your compiled license, and then send a request, and in 1 or 2 days at most, you will receive the credential in order to access the system. I will try to send to maybe to Veronica or somebody else from the CONAE this presentation, because you can reuse in order to get this link, this YouTube link, in which there is a video made by a collaboration between Italian Space Agency and German Space Agency. We show you all the steps in order to register into the system. Just going, skipping the part of PRISMA documentation, you can get it once you log into the system. Just product ordering, which is shown here again. Better than my words, just go on YouTube and see the related video. And the same does apply to new acquisition ordering. There is also in this case the third and last of the videos, which show you step by step how to acquire new order. In order to complete my presentation, just a few slides which show you beautiful PRISMA images. This is on Garda Lake in Italy, Manhattan in winter, Shanghai in April of last year. All these images, this is Port of Piraeus in Greece. All this image was pan sharper, and we're using the panchromatic layer. And the last, I think, is Svalbard Archipelago in Norway. For further contacts, inquiries, and information, you could contact us at PRISMA Mission Management.asi.it.